Welcome to the Deep Dive, where we cut through the noise to get to the core insights you need to know. Today, we're plunging into an incredible, often unseen world behind massive infrastructure projects. Specifically, we're talking about how you move something the size of a small house that weighs hundreds of tons, all in the context of Germany's ambitious energy transition.
It really is a hidden layer, isn't it? We often see the finished power plant or, the wind turbine standing tall, but we rarely get a peek behind the curtain at the just colossal feats of engineering and precision needed just to get the parts there and put them together.
You've hit on it exactly. So our mission today is to uncover the astonishing heavy lifting and transport operations involved in the fuel switch Altbach project by EnBW, transforming a traditional coal power plant into a modern, highly efficient combined cycle gas turbine.
Absolutely. And our main source for this deep dive is truly exceptional. A unique long-term photographic diary by Markus Voelter, capturing over 1,000 images with meticulous explanations.
The Altbach project itself kicked off construction in fall 2023, and it's slated for completion by the end of 2026.
Now let's talk about the stars of the show here, the heavy lift specialists. The Altbach site brought in some of the biggest names. Mammoet, Germany, they were responsible for a huge chunk of the major lifts and the self-propelled modular transporter, or SPMT, operations. Think of those as giant, powerful, remote-controlled flatbeds.
And they weren't alone. Schmidbauer was subcontracted for some really key crane work. And later on, another company, Steil, came in for more crane operations. But if there was one headliner crane, it had to be Schmidbauer's Liebherr LR 11350, Germany's largest crawler crane.
It's a serious piece of kit. To give you a sense of scale, the crane, the load, and all the counterweights can total around 1,700 tons. Handling that kind of weight means the ground has to be perfect. They actually needed another crane, a Grove GMK 6400, also from Schmidbauer, just as an auxiliary crane to help assemble the LR 11350.
All the major components arrived by ship on the Neckar River.
Exactly. River transport is key for items this size. The first major lift documented was the gas turbine itself, August 26, 2024. This thing was a beast. 385 tons net weight, plus another 40 tons just for the rigging, the slings and shackles. To handle it, the LR 11350 needed 300 tons of counterballast on its main body and a massive 500 tons of suspended ballast hanging off the back. That's 800 tons just for balance. The crane lifted the turbine from the ship at a 30-meter radius, up about 30 meters, just to clear some trees apparently, then rotated 90 degrees. Then it carefully placed it onto two Mammoet SPMT modules, 12 axles each, connected side by side. They drove it a few hundred meters and set it down on these temporary storage stands called Elefantenfuß, literally elephant feet, strong name for strong supports.
Elephant feet, I like that. And just 2 days later, August 28th, the generator arrived. Similar process.
Similar idea, yeah, but even heavier. The generator clocked in at 425 tons net weight. So the LR 11350 needed even more ballast for that lift. They upped the suspended ballast to 600 tons. Then through September and October, the crane switched gears a bit, handling steel beams for the machine house structure. These were lighter, comparatively. Some were so light the crane didn't even need the suspended ballast. It could even use something called a runner.
A runner? What's that?
It's basically a smaller, faster hook on the crane. Good for moving lighter loads into position quickly without needing the main heavy-duty hook block. Shows the crane's versatility. So yeah, the LR 11350 spent over a month helping build that machine house. And the source mentions the site was pretty tight, quite cramped, which made placing materials and maneuvering everything a real challenge. Choreography was key.
So things were moving along, but then they needed more reach. The source says in early November 2024, they actually extended the LR 11350's mast.
That's right, November 6th and 7th. They needed to reach higher for some upcoming lifts, maybe lighter, but needing placement further up or over obstacles. So they extended the main boom, the mast, to an impressive 108 meters. That's what, like a 30-story building tall?
Incredible. And then things got even more interesting with another giant crane arriving.
Yeah, this is where it gets visually spectacular. Mid-November, Mammoet's own LR 1500 arrived on site. This second large crane was brought in specifically for tandem lifts, where two cranes lift one object together. Seeing two cranes of this size working together is apparently pretty rare.
And wasn't there a cool detail about how the second crane got assembled?
Oh yeah, get this. The photographic diary shows the LR 11350, the bigger Schmidbauer crane, actually helping assemble the mast sections of the Mammoet LR 1500. So you literally had the big one building the slightly less big but still huge one. Pretty neat cooperation.
Huh. That's fantastic. So by late November, you've got these two titans standing ready. What were they lifting together?
They were getting ready for the really intricate HRSG module installation. That happened between November 2024 and January 2025. HRSG stands for Heat Recovery Steam Generator. Think of them as massive frames just packed with pipes and tubes. They sit in a tall boiler house and capture the super hot exhaust gases from the gas turbine to make steam.
Right, capturing that waste heat for the steam turbine and also for district heating. That's key to getting that amazing 60+% efficiency for the whole plant. But what made installing these modules so tricky? The source mentioned something about how they arrived versus how they needed to be installed.
Exactly. They arrived horizontally on the ships, but they had to be installed vertically standing up inside the boiler house structure. So on December 2nd, 2024, they performed this incredibly complex tandem lift. The LR1500 hooked onto the bottom of a module, the LR11350 hooked onto the top. Working together, they carefully lifted and rotated the module upright. But the real nail-biting part was removing the yellow transport frame, a stabilizing structure, while the module was still hanging in the air.
Wow, wait. They took the frame off mid-lift. How did that even work?
It was a whole sequence. They had to partially unhook, then rehook slings, physically unscrew parts of the frame, and then carefully separate the module from the frame. Only then could the LR11350 take the full weight of the now frame-free module, this one was 90 tons, and lift it into the boiler house.
And it didn't stop there, right? There was an even heavier HRSG lift later.
Yes, January 11th, 2025, another HRSG module, but this one was significantly heavier, about 260 tons. And this lift required both cranes to operate with their suspended ballast systems engaged.
Okay, you mentioned suspended ballast before. What makes using it so complex, especially with two cranes?
Well, a couple of things. First, once the crane lifts the heavy load and puts it down, it often can't just put the suspended ballast back where it picked it up from. Without the main load counteracting it, the ballast alone might be too heavy and make the crane unstable if lowered in the same spot. So you often need auxiliary cranes just to move and restack the ballast later. Big hassle. But the most critical part, especially in a tandem lift, while that suspended ballast is still resting on the ground before it's fully lifted by the counterweight lever, the crane cannot rotate or crawl. So imagine coordinating two massive cranes, side by side, each with hundreds of tons of ballast that needs lifting perfectly in sync before they can even start the main maneuver. It requires immense skill and communication, that finger spits and feel, that intuitive feel and experience, to keep both cranes perfectly balanced and within safe limits till the main load is fully airborne and the ballast is suspended. It's truly a dance of giants.
Wow, that level of coordination is just mind-boggling. Okay, so the HRSG modules are going in. What about the turbine and generator that arrived way back? They were still on their elephant feet.
They were. So moving into late January and through March 2025, it was time to get those main components into their final positions inside the nearly completed machine house. January 24th and 25th, they used those SPMTs again, 2 sets of 12 axle modules, to carefully move the 385-ton turbine from its temporary storage onto its permanent foundation.
And the generator.
That followed on February 1st. The LR11350 lifted the 400-ton generator into place. And interestingly, around mid-February, there was another change. Mammoet's LR1500 left the site, and Steil's CC3800 crane arrived.
Then in March, the source mentions the rotor installation. Was that another super heavy lift?
Not necessarily super heavy compared to the main turbine or generator, but incredibly delicate. This involved lifting the long, multi-ton rotor and guiding it with extreme precision into the generator the stationary part. Imagine threading a giant, very expensive needle using a massive crane. One wrong move, one bump, and it could be catastrophic.
Okay, so major components are in place.
Yeah.
The chimney.
Every power plant needs a chimney, and this one was pretty substantial. It was built off-site in sections. Each section weighed between 45 and 60 tons, about 14 meters high, 6 meters across.
How do they get those sections to the main site?
They used Mammoet's LTM 1750 mobile crane to load them onto SPMTs. The transport involved Mammoet Schmidbauer SPMTs and also some from another company, Schmidbauer. And here's a clever bit. They use stacks of wood, like big wooden blocks, on top of the SPMTs to raise the chimney sections up higher, to make sure they could clear obstacles like site fences and other equipment during the transport route to the final erection point. Simple, but effective problem solving.
Ingenious. So how did they stack them up? Which crane did that?
That job fell to Steil's CC3800. It was equipped with a luffing job. That's like an extra arm on the crane that allows it to reach higher and further, especially useful for placing things precisely over existing structures. The maneuver on May 8th was complex. Lift a section from the north side, rotate 180 degrees, and then slowly crawl with the load taking about an hour per section to position it perfectly on top of the growing Chimney stack, reaching over the power plant buildings. They had to use variable ballast settings on the crane up to 155 tons because the sections had different weights and space for the superlift counterweight system was limited.
A lot of careful calculation there. And around the same time, the LN350 had one last big job.
It did. Its swan song, really. On May 7th and 8th, it performed its final major lift, a nearly 400-ton transformer, lifted it off a ship, placed it onto those familiar elephant feet for temporary storage. And then a significant moment on May 19th, 2025. The disassembly of the mighty LR11350 began.
But the transformer is still sitting there on its temporary storage. How did that get into its final spot inside the building? How do you move a 400-ton box without a giant crane overhead?
First, they used the SPMTs again to move it from the storage area right up to the entrance of its final bay inside the building. Then came the lowering. This wasn't a lift, but a controlled descent. They used powerful hydraulic cylinders, like jacks, positioned underneath the transformer, and they had stacks of hardwood blocks supporting it. They would lower it slightly with the hydraulics, remove a layer of blocks, lower it again, remove another layer, step by step, incredibly carefully, until it was at the right level.
Wow, okay. Slow and steady. But was it perfectly aligned then?
Not quite. It needed a small sideways adjustment, about 15 centimeters, just a few inches. For this, they used special sliding rails placed underneath and small, hand-operated hydraulic cylinders to nudge it sideways with millimeter precision.
Okay, almost there. How did they get it the rest of the way into the bay?
They used a Mammoet hydraulic winch capable of pulling 30 tons. They anchored the winch system using 45 tons of crane ballast leftover counterweights and ran the winch cable through a redirecting roller to pull the transformer straight into its final position inside the bay.
Just brilliant. So after that final transformer move, was that pretty much it for the heavy transport phase?
That was the culmination. By late July 2025, the source notes, the heavy lift teams from Mammoet packed up all their gear, the SPMTs, the load spreaders, the wood, the hydraulics, the winches.
So wrapping this all up, what's the big takeaway here?
Well, the Altbach project really gives us this incredible window into the journey of these massive components. It showcases astonishing precision, immense power, and just remarkable ingenuity from companies like Mammoet, Schmidbauer, and Steil. These logistical feats, which mostly happen out of sight, are absolutely fundamental to our energy transitions and pretty much any large-scale industrial project.
Yeah.
It's this powerful mix of brute force and incredibly delicate engineering that, frankly, doesn't get the spotlight nearly often enough.